Hey guys, it's Ms. Simpson and it's time for math today. We are going to be talking about input-output tables and how to solve problems involving input-output tables. So to begin with, let's talk about what input-output tables actually are. They represent relationships through number patterns, and we use input-output tables for conversions. We use input-output tables for adding and subtracting, multiply, dividing. We have used input-output tables a lot this year. Input-output tables can be vertical, which means up and down like this, and you read them from left to right, or they can be horizontal like this one. You can read them from top to bottom. We always read from input to output. So it's like saying the input times your rule gives you your output. So they can represent relationships involving addition, multiplication, subtraction, and division. So what you do is you look, say for addition, at your input, and you see 21 plus what will give you 29. Well, you know 21 plus 8 will give you 29. Well, does 23 plus 8 give you 31? Yeah. 27 plus 8 give you 35? Yeah. So does 31 plus 8, what does it give you? 39. So your rule would be to add 8. Your input plus 8 gives you your output. For multiplication, you would look at this one. 2 times what gives you 18? 9. 4 times what gives you 36? 9. 6 times what gives you 54? 9. So 8 times what? 8 times 9 is 72. You're right. So my rule would be to multiply by 9. So we are looking for the relationship between the input and the output. So I'm going to do some practice problems with you, kind of like you're going to see on your STAR test and in your worksheet today, and just like in life in general. So most of the time they're going to show you an input-output table that looks like this. It gives you an input position, a numerical expression, and an output value. Your input position would be 1, 2, 3, and 4. So they're saying 1 times 9 is going to give you your output. So your input times 9 gives you your output. So does 1 times 9 equal 9? Yeah. Does 2 times 9 equal 18? Yeah. Does 3 times 9 give you 27? Yeah. And does 4 times 9 give you 36? It does. So what would be the value in the 15th position? So you have to apply this numerical expression to your input to get your output. So 15 times 9. I want you right now to pause the video and I want you to do 15 times 9 on your own. So 9 times 5 would be 45. 9 times 1 is 9 plus 4 is 13. Is there an answer choice? There sure is. So your output is 135. I want you right now to try this one on your own. I want you to pause the video and I want you to try on your own. So what you should have done is notice that your input, it's saying plus 183 will give you 186. So 5 plus 183, 7 plus 183, 9 plus 183, those all give you your output. So they're going to ask you if the input in the table was 19, what would be the output? So 19 plus 183, and what would that give you? I got 9 plus 3 is 12, 8, 9, 10. I got 202. Did you get 202? Give me a thumbs up. All right. Okay, so now you might also see some that look like this one right here. So let's read what it says. Anton wrote a series of numerical expressions to generate a number pattern. Which input-output table matches his number below? So we've got 67 minus 1, 67 minus 2, 67 minus 3. So these numbers right here are our input. Minus 67 is going to be our rule. So what it's telling you to do is take 67 and subtract it from each of your inputs. That would be 1, 2, 3. So you just continue with all of your inputs and you see which one works. You replace the 1, 2, 3 with the inputs that they give you and see which one works. So right now I want you to pause the video and I want you to go through and see which one works. So when I did it, I started with this one. And 67 minus 22 is 45. And that didn't even give me the right answer. 67 minus 10 is not 77. 67 minus 13, 3. Oh, that's 54. 67 minus 17, that's 50. 67 minus 19, ooh, close. That's 48. So C doesn't work. So my only answer is 8. A, 67 minus 10 is 57. 67 minus 20 is 47. 67 minus 30 is 37, going down, down, down. All right, so now that you kind of know how to solve those, I want you to try this one on your own, and then we'll check your answer. Okay, Naomi wrote a series of numerical expressions to generate number patterns. Which input-output table matches their number pattern below? 4 times 1, 4 times 2, 4 times 3. So if the pattern kept going, 4 times 4, 4 times 5, 4 times 6, you would have 4 times 5, 4 times 8, 4 times 12. So which one, if our rule is times 4, I'm going to go ahead and write that on each of our inputs, and I'm going to go through and check which one works. 4 times 5 is 20. 4 times 8 is not 40. 4 times 10 is 40. 4 times 20 is not 50. 4 times 15, I'm going to have to work that one out. Oh, it's 60. 4 times 18, I don't think that's going to work. Nope. So my answer's got to be D. Let me check it. 4 times 7 is 28. 4 times 12 is 48. And 17 times 4 is 68. Woohoo! And that's my answer. So let me see if they have another one that we can go ahead and practice on. On your assignment today, they have ones that give you the numerical expression. They have one that gives you the pattern, the number pattern, another numerical expression, and then they have this one. Guys, do not let this fool you. It is looking for your rule. So does 6 times 6 give you 54? No. Does 6 plus 48 give you 54? 6 times 9. Which one of these is your rule? Which one makes sense with all 3 of these values? Don't let this confuse you. It seems silly. They draw all these pictures just to ask you what the rule is. Don't let it confuse you. That's one of the easiest ones you'll do. You're just going to go through and try each of them. That one doesn't work, so you're going to go on to the next one and try each of them, and then go on to the next one and try each of them and see which one fits. All right. I love you guys so much. I hope you have fun with this input-output assignment today. I hope it's a little bit easier than the word problems that we've been doing recently. All right. Have a good day.